So hello guys. In this video we learn how to draw the full header layout in the edit software. So before drawing the layout, let's have a look on the Cmos circuit of the full header. This is the circuit of the full header Cmos circuit. Here we use the mirror logic to draw this full header circuit, because in the mirror logic the Pmos and Cmos just like a mirror image each other, as you can see C in AB and C in AB. If you draw a line between there to there, you see the PMOS and NMOS are the in the mirror fashion, connected as a mirror fashion. There, that is the expression of the C out, and that is the expression of the sum. And here we consider the Euler path, as you can see A B C in AB, and for the Euler path of the sum expression, that is A B C in C out, A B and C in. And here is the stick diagram for that. You can see also here, that is the A B C in A B, and from the C in we extract our C out, not C in. When we draw the layout, you can understand in a better manner. First, before draw the active region and active region and select region and well, and for the P and MOS and select and region, active region. First you have to draw all these things and place the gate in that manner. So I think we have to draw the layout first, then we understand how these are connected and how we have to connect all these things and all the contacts and regions. Okay, so just open the edit software. Okay, open the edit software. First of all, we have to replace the setup file that we are working since our first assignment, that is mar120. So select mar120 file. Okay. There are two options available there. Either we can draw first the active contact, then metal, then active layer, and then the P select, and then the anvil for the PMOS. Or we can choose first draw the anvil, P select, active region, and the polygate, and then metal layer, and then the active contact. There are no difference between both of them, but from the manufacturing, or we can say that if we fabricate our layout, so the process is followed, that first we have to define the anvil, and then the P select, and then the active region, then gate, then contact, then metal layer. But from the drawing purpose, there is no necessary thing. So first I decide, then first I draw the metal contact, and then the means active contact. So that is on active contact. The active contact size is 2 cross 2 lambda. Okay, so first draw the 2 cross 2 active contact, and the metal layer surrounding this contact is apart from 1 lambda, means distance between the active contact to the metal 1 layer is approx 1 lambda. Okay, so and now we create a polygate distance between the from the Active contact is just about the 2 lambda. So now we create a polygate length of 2 lambda. As you can see here from the ruler, distance between the active gate and the poly is 2 lambda. Okay, now we copy this thing, this all metal and active contact. Select this, Control C, Control V, continuous pressing Alt, double click on that, drag it where you want. Okay, now we create active region. The active region is the distance between the active region and the poly not poly. Active contact is 1.5 lambda minimum distance. That's the minimum distance. You can draw a active layer like that. Okay, now after that, the distance between the active layer and the p select is 2 lambda. Okay, is this 2 lambda, and this is 2 lambda, this is 2 lambda, this is 2 lambda. Now we create a p select for this region, for Cmos. Okay, our p select region is ready. Now the distance between the active and the well is 5 lambda, and we already draw a 2 lambda distance of the our p select. Then remaining distance is 3 lambda. So that is the ruler, I think that is ruler. So 3 lambda. Okay, 3 lambda. So now we create a well at this distance. Okay, so use ruler, 3 lambda, 3 lambda. Okay, uh, 3 lambda here and 3 lambda here. Now we choose the anvil for this Cmos. Okay, that is the Cmos. Now check the DRC error. No DRC error. Okay, fine. For our here in this layout, we are not sizing the transistor. We simply draw the layout. Okay. Now what we can do right now, we have to draw the NMOS. So the select region for NMOS and PMOS, here we are taking same. So N select region, the N select region is what size we can draw. The size of the P select is 17 into 9. So now select the N select region into 17 to 9 ratio, and that is the 17 into 9. 17 into 9, perfect. That is 17 into 9. And don't need to draw all these things again, just copy all these things, Control C, Control V, continuous pressing Alt, double click on that, drag it and place in right manner. One, two, that is that is 17.5. Okay, 17 to 9. 1 2 1 2. Okay, now this is okay. Now extend this gate toward down. Continuous pressing alt, double click on the edge of this, polygate, and extend this down. Okay, there is some mistake, I think. Now this is okay. Double click on, select this, continuous pressing alt, double click on that and extend this gate also. Okay, select this. Okay, now our PMOS NMOS is also ready. Check the DRC error. 3 DRC error. I think DRC error comes from here. Well, minimum width is, oh sorry, here we take well, we don't have to take well, we have to take select region. Okay, so delete it and select region and make a well of 17 into 9. Okay, then and select it and drag it, and now check the DRC error. Okay, no DRC error. Okay, now we have to extend this. So okay, so till now we are drawing our CMOS inverter circuit. Now what we are drawing, we are drawing the full ladder circuit. So A, B, C, in A, B, C, A, these all are the gates of the transistor. So we have to click on that, continuous press alt, double click on that edge and move it where you want. Extend it also, extend it, and also extend this thing. Select this and extend it. Okay, extend it. Now drag it, extend it. Okay, extend it. Now what we can do, we also extend this P select region. Okay, extend it, and also extend this active region. Okay, and this extends some bit something. Okay, so you don't need to draw all these things again and again. Just click on it and Control C, Control V, continuous press Alt, double click on that gate and drag it where you want. Okay, Control C, Control V. The main thing is that the distance between the gates of the individual transistor is what is 6 lambda. So we have to draw these gate apart 6 lambda. Make a ruler 6 lambda. Okay, and 2 for 2 6 lambda and 2 for our polygate. So make a new from 2 lambda 6 lambda. Okay, 2 for our polygate, that is 6 lambda, 2 for our polygate, for our polygate, and that is 6 lambda. Okay, now you don't need to draw all this gate and all this stuff again and again. Just control C, control V, continuous pressing alt, double click on that and drag it where you want. Control C, control V, continuous press alt, drag it where you want. Okay, this is actually the fast manner of drawing of the layout. Okay, that is for our convenience. Just write there a note. That is A, that is B, that is C, that is A, that is B. Okay, our gate are ready, and we have to draw the contacts. As you can see in our stick diagram, there are contacts. A, these are the contacts. You have to draw 4 contacts. Okay, one contact to the left of the A, and one contact to the right of the A, and all these 4 contacts. Okay, I think one contact is missing here. We have to connect this point to the ground. Okay, but no problem, we can draw in the layout. Okay, so copy it, control C, control V, continuous press alt, double click on that and place wherever you want. Okay, how many contacts we need? A to the left, 4 contacts. One contact from the left to the A, and right to the C. Okay, that is 4 contact, I think enough. And you copy these contact, control C, control V, continuous press alt, place it, and you also extend this region. Okay, extend this region. So now we connect these. We have what we connect in the stick diagram. A to the ground, that is not the matter. I think we can connect to ground, but first we connect these things, these contacts. You have to draw first. Connect these contacts, A and B. The minimum distance of minimum width of the metal layer is 3 cross 3, and minimum distance between metal to metal is something around 3. Now check the DRC error. No DRC error found. Okay, and copy this, control C, control V, continuous alt, metal to metal distance is 3 lambda, control C, control V, click on that. Okay, control C, control V, click on that and copy these things. Now check the DRC error. No DRC error found. Okay, who's messaging me? No. Okay, no DRC error found. Now what we have to connect? C out. Actually, C out is passing between these two contacts, these two connections. So all these distance maintaining 3 lambda means C out wire distance between these connection 3 lambda, and this is also the 3 lambda. So we have to drag all these things towards the down, means we need this distance 3 lambda, okay, and this distance for our C out connection, and this 3 distance V for our this connection. So we move this whole thing towards down to the here. So select all this thing, continuous press alt, double click on that whole thing and place it here. Now it is okay. Now draw the metal layer for this C out. Okay, and from here to here, C out. Okay, to extend this, continuous press hold, double click on that edge and move that here. Okay, now check the DRC error. No DRC error. Okay, no DRC error found. Where we reached, we counted here. Actually this is where is the marker drawing. So actually this area, oh sorry, this area, this this area, this area our C out. Okay, and this area our sum expression. Remove this. Okay, so this is our C out bar expression. Now we draw the A, B and expression for the sum also. What is the expression of the sum? Sum sequences A, B, C in A, B, C, C out, A, B, C. Okay, so don't copy all these things, just copy all these gates, control C, control V, continuous press alt and drag this thing where you want. Okay, deleted. B, that is our A, that is B, that is C, and how much gate we have left as A, B, C. C out, A, B, C, 4 gates we have to draw. So copy all these things, control C, control V, continuous pressing alt, double click on that and move towards right. Okay, 1 2 3 4 5 6 2 3 4 5 6. Okay, that is our all the gate have been drawn. And also you have to extend this active region towards right. Also extend this again, and also you have to extend deselect region. Okay, the minimum distance between the gate and the edge of the active region is 5.5. So this distance here is 5.5. Okay, so you need to further extend this and also extend this. Okay, now you have to extend this also, reduce this is also overextended, I think. 3 1 2 3. Okay, extend this also. Okay, distance between the gate and the edge of the active region is 5.5. Okay, that is okay. Now it is okay. Now we check how much contacts we have to connect all these things, all these gates and source and the drain of the region. Now, so check here. 1 2 3 4 5 contacts side by side from starting of the B of the right of the B, just right of the B. Okay, here. So we need to draw all these contacts. We just copy all these contacts, control C, control V, and place here accordingly. Okay, 1 2 3 4 A B C, that is our, that is not B, that is C out. Okay, that is C out. And here we can see the contact is A to the right and C to the right. These two contacts are have to be connected. So make a contact here. You just need to make a contact. Just copy this, control C, control V, and make a contact here. Here you can see that A to the left and C to A to the right and C to the right. A to the right and C to the right are connected. Now B to the right, here B to the right and here B to the right connected to the VDD. The VDD and ground connection we make later. And one more connection is C to the right, that is our C expression. Oh sorry, that is our sum expression, sum bar expression. How much contact we have to draw? Only C contact. Okay, so copy this, Control C, Control V, continuous pressing Alt, double click on that and place it. Okay, and same contact you have to draw in the Nmos region, so don't need to draw all these things again and again. Just Control C, Control V, continuous press Alt and move these contacts. Okay, and also this Control C, Control V, place here. You also extend this thing because ultimately we want this contact here, C out. This is our gate of the C out. Okay, so Control C, Control V, continuous press Alt, drag this contact, drag this metal, Control C, Control V, continuous press Alt, 1 2 3, 1 2 3. Okay, we also make a contact here where we take our sum expression. Okay, that is from here that is our sum expression. Okay, uh, I think there are some constraint. I think. Okay, let's see. We make a contact here. We have to make a contact here. Okay, so select poly. We make a poly contact. Where is poly contact? That is, I think, poly contact. Okay, so poly contact of 2 cross 2, 2 cross 2 poly contact. Over it we have to draw a metal layer. Okay, and now we have to connect this, and over it we have to connect our poly layer 1 cross 1. Poly layer, we have to drag this. But the thing is that the minimum distance between the metal layers is just 3 lambda, but that is not the 3 lambda. That is, I think, the 2 lambda, and this is also the 2 lambda. So we have to extend this thing. Okay, we have to extend this thing. Now you can see this is so weird. I think no, okay, okay. Now we have to extend this thing just little bit. Okay, 1 2 1 2. I think we have to extend this thing little bit down. 1 2 3 1 2 1 2 1 2 3. I think we have to extend this thing little bit down. Now check the DRC error. 3 DRC error. This, oh sorry, poly to metal contact is 3 lambda. Metal to metal is 3 lambda, but that is not 3 lambda. We have to more. We have to drag this thing more towards the right. Okay. Now I think that is okay. And poly to poly. I think now poly rules are violating. I think these come. Yeah, I know. This distance should be 2 lambda. You can drag also these things here and here and here. There are many techniques to minimize these things. After all, you have the designer, you have the freedom to. Now check the DRC error. 2 DRC error, where 2 DRC error comes. Where the DRC error comes. What? Oh, okay, that error. Minimum to this region. Okay, no. Now it is okay. No DRC error. Okay. How many corrections we left here now? Right now? Some expression is just taken from the left to the C out. Okay, that is our C out. That's in don't sorry. This is our some bar. So we have to make some expression, invert that to use that. So invert some expression, we have to use a some one more inverter. Okay. So make an inverter here. 1 2 3. Okay, 3. Extend this also. Okay, extend this also. Our C in to the VDD, left right to the C in VDD. We have to make to one more connection. That connection copy paste and control the result and double click on that, drag it where you want, Control C, Control V, and okay. So one more thing here, we in this layout we are sharing lots of source and drain region of the different transistors, and you can check in this diagram how we can sharing all these drain diffusion and source diffusion regions. You can also check. Now we make a inverter for this, mm, for this sum expression. Okay, so Control C, Control V, make another inverter, and this inverter also shares its region diffusion region between the C, and make this polygate connection. Control C, Control V, continuous press Alt, drag. Okay, that is our inverter, another inverter. Place these things in little bit down. Okay, now I think there is some mistake. You make it more here. Now it is okay. Control C, Control V, continuous press Alt, drag this thing. That is okay now. Okay, make the distance to 1 2 2. Okay, make the distance 3 0 1 2 3. Okay, that is 3. Do that thing here also. Actually, you drag this thing little bit here also. Yes, now you can connect these gates here. 1 2 3. Yeah, metal to metal. Now we have to check the DRC error. Okay, now click DRC error. So okay, no DRC error found. And now we can connect the VDD to all these required connection that connect to the VDD. Okay, so this is connect to VDD, I think. That is connect to VDD, and that is connect to VDD, and this is also connect to VDD. No, this is not connect to VDD. This is connect to VDD. Okay, and this is also connect to VDD. Okay, now we make a ground connection, and this is our connect to ground, and this is our connect to ground, and this is our connect to ground, and this connection is our connected to ground. Okay, and connect all the gates accordingly. Actually, this A and A, all these AR should be connected. So down here, as down it get little bit, not down. All the A should be down, otherwise it's create a lot of disturbance. Okay, A connection should be downward, to the downward. Okay, A, where is A? That is A, and that is also A. And now you have to connect all these A from the by the one poly layer. Okay, now A are connected. So extend this B up. Okay, not whole B, just the extension of this A, this A, not A, because we are connected A from the bottom of the layout, so don't need to extend this A. Okay, no need to extend this A. Extend B, no need to extend A, and B, extend B, okay, extend B, and C, you have to extend C also. Extend C. Okay, and this is C out, because C out is coming from there, you don't need to extend C out. Okay, you don't need to extend the C out. And this is A you connected from the down, so you don't need to connect it. Actually this is little bit, now this is okay. Now B, you have to extend the B upward. Okay, and you also extend the C. Okay, now you have to connect all these things by the different metal layers. Okay, that is A, B, C, A, B, A, B, then A, B, C in, that is B. Okay, I think that is not visible here. That is B, that is also B, and that is C, that is B, and that is C. Okay, so you make a connection of these ports. This is what, this is B. you have to connect all these B's together. that that B, that B, that B, and that B. Okay, so make a port, copy this port, control C, control V. Okay, extend this. That is our A. Okay, and now control C, control V. Move this little bit up just for our convenient. Okay, so what, that is our A. Okay, and that is our B. Now we connect all the B. Now we connect all the B together by the metal layer contacts. Okay, this is our metal layer until the B. How much layer? The width of the layer, I think is 3. Okay, okay, that is a 3 also. Now we have to create a poly and metal contact. Just copy this contact and paste it here, because that is our B contact. Okay, B, that is B, that is B, and that is B. 3 contact we have to need. Control C, control V, copy. Okay, control C, control V, and that is our last B connection. Okay, okay, that's our last B connection, and last is C, C in actually. Now place it here. Okay, extend this. Extend this C in. Okay, and connect all this C. Where is C? B, B. Actually, this is not the C connection. Delete it. This is not the C connection. We have to connect this here. That is B connection, B connection, B connection. Now that is our C connection. Okay, we have to connect all this C to the this layer, this C connection. Okay, now that is our C connection is ready. Okay, that is not B, that is C. Okay, that is C in. Okay, now you can check all the C where A, B, C connected, A, B connected, A, B, C, C out, A, B, C, and this last inverter for our sum. And can also write here, that is our, not the port, we are not defining the port, we are making another contact, that is our sum. Okay, and select the via. Okay, that is via 2 cross 2 via, 2 cross 2 via, and the metal 2 layer. Okay, and the same thing you have to copy, not copy, because here we are getting only C out bar. Actually we are have to draw one another inverter to get the C out, not C out bar. Okay, so you can make another inverter here and connect it and get the C out. That is our VDD, that is our ground, and all these connections are made. And now check the DRC error, 6 DRC error. Where DRC error from? Oh, that DRC error. Poly to poly contact is 2 lambda, that is not 2 lambda, I think. So don't worry, just drag it little bit down, or not. Drag it down. I think that is not the correct way, because this metal layer and metal layer also are close enough to make a DRC error. So we down it little bit down. Okay, and we can move further down it. Okay, this is down it. Okay, now move these things little bit down. Now this is okay, I think. Okay, no DRC. You can check also the cross-sectional view of the transistor, how this transistor are looking in the cross-sectional view. Pick. Okay, now you can see all the transistor in 3D view, or not 3D but in the cross-sectional view. Okay, and check this also, how these connections are made. Oh, sorry. Pick and check. Check this C out, this C out is connected here, and we are getting it here, and all the metal layers are differentiate to the below, and this is our via, and this is metal 2 layer, this is metal 1 layer. You can draw any complex circuit and no DRC error comes. Okay, the first thing is that in this, not this, where the this Euler path may be different, and this Euler path may be different, but you have to minimize the area of that PMOS and the CMOS. So that is finished. I think layout is finished. You can draw your own layout. Best of luck, guys. Okay, bye.